Let's go to page 167 and do number 207. Okay, for 207 you have a trapezoid. Okay, so let's go and draw the trapezoid. And the line join the midpoint of the diagonal of the trapezoid. Okay, so you have the diagonal, and here is your midpoint. So basically, the join the midpoint, this will also give you the median. Okay. So the line join the midpoints of the diagonals of the trapezoid have lengths of 3. If the lower base is 97, what is the shortest base? Okay. So again, if you add and divide by 2, you get this length. If you subtract and divide by 2, you get this. So you get 97 minus x over 2, will give you the 3. So for me, just go and solve. So 97 minus x equal to 6. And move this over, so plus x, and minus 6, minus 6. So you got 91 is equal to x, and that's it. Okay, so again, if you know the shortcut, it's very simple. Okay, let's go to 2008. Okay, 208. Okay, so ABCD is a trapezoid. So the trapezoid, and with a measure of AB, so AB is twice of the DC, so I'm going to call this x, and this is 2x. And let E be the point of intersection of the diagonal. So this is point E. If the measure of diagonal is AC, of the AC is 11, so AC equal to 11, then find that segment of EC. So you're looking for this one over here. Okay, so for this one, what you need to do is first you need to draw the median. Okay. And then next, go and figure out the length over here. So so this came from subtraction. I'm going to call it F and a G. Okay. So you're looking for EC. So these are the information. Okay, so again, to find the FG, so FG equal to the difference divided by 2. So FG equal to x over 2. So this is x over 2. Then what you need to do, next step is you need to go and put all the ratios. Okay? So notice this is 1 to 2 and this is 1 to 2. So look at the triangle. So this over here. So the corresponding, so you can just use the y. So this would be y over 2. And this over here would be y. Right? Because it's x, right? So it would be y. X over 2, so it would be y over 2. This is 2x. So this will be 2y. So by looking at these, you can see that AC is equal to 3y. Right? See that? AC. So this is 2y for the big triangle. And so basically you have the big triangle and the medium triangle. So the ratio is 2 to 1. Okay? And so you got 11 equal to 3y. So divide by 3. So y equal to 11 over 3. So once you find y equal to 11, 3, and that's it. So EC equal to 11 over 3. Now in another problem, they ask you for the FE. So FE would be 11/6. And sometimes they ask for AF, sometimes they ask for AE, sometimes, so they usually ask something along this diagonal. Okay, but once you get these three numbers, you can set up your ratio and you can answer the question. Okay, let's go to 209. Okay, so you need to prove that connecting the midpoint of side of any quadrilateral, a parallelogram is formed. Okay, so let's go ahead and, so you just have a general quadrilateral, okay, and you connect the midpoint of each side. Let's go and label this A, B, C, D. And so this would be a E, F, G, and H. So if you connect this midpoint to each side, that you get a parallelogram. Okay, so for this, what you need to do first is you need to go ahead and draw the diagonal. Okay, and then from here you look at each triangle. So if you just look at this triangle and this triangle, because this is midpoint, so when you connect the midpoint of the two sides, it will become parallel to that. Okay. So again, so you first you draw AC, and then from there you're going to get EH is parallel to AC, and you do the same thing on this side. So you're going to get FG is parallel to AC. Now since this is parallel to this is parallel to that, so EH is parallel to FG. So that means, so one we go, so naming this are parallel. Now you do the same thing. So you draw DB, so draw that, and you can look at this two triangle. Because again, when you're connecting the midpoint of the two sides, then this median would be parallel to this. Okay, so from here, you're going to get EF is parallel to DB, and then you do the bottom triangle over here, so you're going to get HG is parallel to DB. Now since both of these are parallel to DB, they will be parallel to each other, so EF is parallel to HG. Okay. And so now you got two pairs of the parallel lines. Okay, so you have two pairs of parallel sides. So that will give you, so therefore, ABCD is a parallelogram. Okay. Okay, let's go to 210. Okay, so the picture is giving. So you have a square, and then you have the diagonal, and then you have also the square, okay, so you have the A, B, C, D, E, F, G, H. So AB equal to 1, so this is a square, so AB side equal to 1. And you find the area of the EFGH. You're looking for this area over here. Okay. Okay, so to find the area, we need to find the length of the side. So since this is a square, so this would be x, 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 and x, right? Okay, now this is a square, so when you cut a diagonal, this would be a 45 degrees. Okay, and since this is a square, so these two are parallel. So if these two are parallel, then this would be the corresponding angles. So this would be 45 degrees, and this is 90. So this is also 45 degrees. Okay, and this is the right angle. So now you have 45 spatial triangles. So if this is an x, this would be also x right over here. And same thing on this side, this would be an x. So you can see that the diagonal of this is a 3x. So 3x equal to square root of 2, right? Because this is a 45 spatial triangle. So you got one square root of 2 over here. So it's 3x equal to square root of 2. So divide by 3, divide by 3. So x equal to square root of 2 over 3. So the area of EFGH is a square, so it would be the side times side, so it would be square root of 2 over 3 times square root of 2 over 3. So EFGH is equal to 2 over 9. Okay, let's go to 211. Okay, you want to prove that if a quadrilateral ABCD is ortho-diagonal means the diagonals are perpendicular. Then AB squared plus CD squared equal to BC squared plus DA squared. Okay. So let's go and draw our ortho-diagonal first. Okay, so again, ortho-diagonal means diagonals are perpendicular. Okay, so you could just have any quadrilateral. Okay, so any relation. Okay, so now you label A, B, C, D, E. Okay, so let's go and get all the area of each triangle. There are 4 of them. So if you look at triangle AED, you get, so look at triangle AED, this one over here. Okay, so if you apply the Pythagorean theorem for this triangle, so you're going to get AE square plus DE square equal to AD square. Okay. And I'm going to, next one, triangle AEB. So you get AE square plus BE square is equal to AB square. Then let's go and get triangle BEC. So BEC, you get BE square plus EC or CE square equal to BC square. And then the next triangle, so triangle DEC, you get DE square plus CE square is equal to DC square. Okay. Okay, well, first let's write down what we try to prove. We try to prove that AB square plus CD square equal to BC squared plus DA or AD squared, doesn't matter. Okay. So let's go and gather our terms. Okay, so so let's go and add this and this together. So when you add these two together, and I'm going to put this on here. Okay. So see this side over here. So I'm going to get these two together, and A, B, and C, D is these two. Okay. Well, let's go and add these two together. Okay. So if you add these two together, so you got AB squared plus DC squared. So these two together will equal to this and this. So it will be equal to AE squared plus BE squared plus DE squared plus CE squared. And if you add these two together, you're going to get AD squared plus the BC squared. So when you add these two, so these two, you get that. You add these two, you're going to get AE squared plus DE squared plus BE squared plus CE squared. So by comparison, okay, you see this matched with these. Okay, so these two match, these two match, these two match. They match. So you can see that. So this equal to that, this equal to that, and they are equal. Therefore, AB squared plus DC squared equal to AD squared plus BC squared. And now we're going to rearrange the term. So we try to match that. So rearrange things a little bit. So instead of DC, I'm going to have, okay, so you got AB squared plus, so DC and CD are the same. So that's going to switch the letters. And I'm going to switch the term, so put this in the front. Okay, and put this in the back and switch the letters. Okay, so you can, this is the same, switch the letters. Over here, switch the term, switch the letters, and that's it.